Yeah, I'm a chemist by degree, and through chemistry, I kind of got it. Through chemistry, I got into image analysis, and through my PhD, particularly, I was doing image analysis of coal, and then I followed on doing image analysis of crystals. So this is why I'm particularly interested in processing images and extracting information from images. So my project is called Seamless. It's about creating seamless patterns from images and trying to automate that process. So what are seamless patterns? They are used in all sorts of industries like textile industries, print media industries, and also in the gaming industries, and also for 3D virtual environments for like architectural software, for instance. Um, Here you can see some examples of different seamless patterns that you can tile into a repeating pattern over a surface. So in this industry, there's quite a lot of demand. All the game developers are using AI-generated textures in their workflows, and they use them for props and characters and sort of some of the landscape and things like this. Also in the textile design industry, which is a large industry, they're used very often in patterns on fabrics. Also in graphic design, patterns are used quite a lot for things like packaging materials, for instance, and as well in the architectural software area. You have textures being applied to walls and interiors of houses, things like this. So the question is, how do you design a seamless pattern normally? How would a graphic designer design a seamless pattern? Well, they start off by drawing in the middle of a piece of paper, okay, leaving the edges of the paper bare, and then you cut the paper in half and you rearrange the two halves of the page, one over the other side, vice versa. And then you draw on the middle of the paper then. And then you cut in the other orthogonal direction across the middle of the paper, and then also swap these two halves, and then you draw in the middle of the seam there as well. And when you rearrange the paper back into the position it was in originally, you have then this seamless pattern because all the edges have now got a copy of the other edge on the edge, if you see what I mean. So the important thing is the edges of the image should seamlessly blend into the edges of the next image in tiling. So this is the image I use as my test image. It's Lena. It's a very well-known image processing image. And what I like about Lena image is that it has a lot of interesting features. So you've got this mirror, you have a hat, you have this feather coming from the hat, you have the face, you have some other reflections, and you have this quite difficult background to process too. So what I've done here is a kind of simplified, my first approach to this was very simplified a long time ago. And I did an image blending, which basically just averages the pixels over the edge. And it has a distance function. So the further away you go from the edge, the less the images are blended. And you can see here that the problem is that the textures are overlaid on top of the other texture, and the information is kind of lost. I mean, it works as a kind of nice pattern. It is seamless, but it's not, all the information is being mixed up. So a better attempt is using what's called quilting. Quilting is a kind of like error minimization process where you overlay an image on top of another image, and then you find the cut that minimizes the error between the two images, like a best cut through those two images. And this has been done in this image on the bottom left here. And you can see that when it's been tiled, then the tiling is also quite nice, and you don't have this overlay of the different textures. So the question I asked here with this is how do we use AI to use the information that AI can provide to better perform this partitioning of the image so that you can better do this mirroring and create a seamless pattern. So the first AI model that I used was called Dino. It's a model from Facebook, Meta, and it's trained on 142 million images. And it's like a patched-based neural network. So it has as its basis a convolutional neural network, and then it gives these patches, these 16 by 16 pixel patches. And you can see in the image on the bottom right here, the size of the patches is quite pixelated. But you can see that with clustering here, well, actually the principal component analysis has managed to find the clusters in the image. So it's identified the different types of semantic content in the image. So you've got like the red hat being discovered here, you've got the feather being discovered, as you can see it in a different color, and you see the face and the body also kind of semantically linked here. And also some of the mirror as well. So it's really found the areas of an image which are like one unit, you know? So we cluster these PCA blocks using something called HT scan clustering algorithm. And then you see these regions here. And you can see this blocky artifacts because the Lena image here has got these blocks around them. So it's not perfectly segmented, but it's actually corresponding to the different parts of the image. So there's another neural network that's also been developed by Meta called SAM, Segment Anything Model. And this is kind of like an improvement on Dino in a way, in that it segments the regions of the image. And you can see here in the image at the top, then it's segmented the hat, the feather, the body, and it's done quite a good job. But the trouble with this SAM is that it doesn't create regions for everything. Some of the pixels are black, they haven't been classified. So we have to deal with these black pixels. So what I've done is combined the Dino classification with the SAM classification for the region, and this blends both neural network outputs together so that it deals with these black pixels. So you can see in the image here that some of this black seam has been removed and merged into the neighboring regions, and also this large black area has now become a region of its own. So what can we do with this? Well, we found all the different regions, so then we can mirror those around the edge of the image and create like a kind of a mirrored border. So that's what we've done here, or what I've done. And we create this mirrored border, and then we can, with the central objects, replace them into this border, and then we have like a seamless rapport of the image, which can be tiled. Another thing that I've done is background tiling. So in this case, I identify a region of the image. You can see here in this black picture here, you see the background of a Lena image. And this is a scaled up image that's twice as big. And you can see that we've taken this background region, and then I've like tiled it across the image to use as a background. Okay, and it's like a seamless background. And then the central objects then, Lena herself, is then superimposed back onto this background. So then you have this kind of pattern. And this image in the top right is like the quilting. So quilting is this process by which you can merge regions without them having visible lines. So obviously it's quite a difficult thing to do with real world images. And there's a few examples here. So there's this seagull image on the background of a beach. And you can see here the rapport on the left. And then on the right, you've got this 3x3 tiling of that. We have some cheese plant image here, and that's also been tiled quite nicely by this approach. And also you see the report, which is actually resembling quite a nice texture that you could use on a building or so. And here we have also a difficult cheese plant image with this black and white background, which is also being quite nicely tiled into a 3x3 pattern. So I'd just like to mention that this could form the basis of a pattern making software. So yeah, I can imagine that these objects can be moved around or added, copied, and really have a nice pattern making software. This is where I hope to go with this in the future.